Hello, folks. So this is a video presentation for Chapter 8. In this chapter, we're going to be talking about mostly arrays and file handling. So working with um, files that actually reside on your computer, reading from those files and writing to those files. So keep in mind in this video again, I'm going to be asking some questions that you're going to need to answer in a Google Doc. So look out for those questions throughout this video. So let's get into this. So one of the big topics in this chapter is arrays. We'll talk about what arrays are and how to initialize them, how to declare them, and how to access the elements in an array. So an array, which we'll get into a little bit later, is just a variable type, but it's a variable that can hold multiple values rather than just one value. So we'll talk about how to access those items in the array, and typically we use a loop to do that. We'll talk about the redim command, which allows you to resize an array that you've already declared as a certain length. And we'll talk about ways to determine the number of elements in an array using the length command. We'll talk about a new type of loop, kind of like the for next loop, but the for each loop. It's used specifically for working with arrays. Talking about two-dimensional arrays, which is kind of just like a table or a spreadsheet. So items in the X and in the Y. We'll talk about reading and writing to text files. That's kind of a really important topic to kind of understand as you're moving forward in your career. A lot of times when you need to transfer data from one application to another, you'll put it in a text file or have to read those text files in. So we'll talk about how we can create a text file from within our applications and how we can read data in text files and pull them into our applications. The guided program walkthrough in this chapter looks at depreciation, which is just kind of how businesses look at their assets they have and kind of write down the value of those, the declining value of those assets as the years go by. So if you buy a truck in your company over the next 5 years, that truck is going to decrease in value, and there's tax advantages to that. So we're going to be writing an application to kind of calculate that depreciation. And kind of the last thing we're going to be talking about in this chapter is multiple form applications. So most of the applications we've done so far this year has just been one form. The applications that we'll be doing in this chapter, some of them will have multiple forms. Most real-world applications have many forms. I've worked with applications that have 20, 30, maybe even 50 different forms in complicated applications. And we'll talk about how, if you need to access objects and variables and other things in other forms, how you do that. So this is just kind of a screenshot of the application you're going to be working on in this chapter. So you're going to be actually pulling in a lot of this data that you're seeing in the screen from a text file. So you won't be entering all this data. This data is going to be created for you. In real world applications, that's really the way you do things. You're usually going to pull data from a database, but we're not up to databases just yet. So we'll be talking about pulling data in from a text file. So this application, it's an application for a food truck. So that food truck has inventory items, and you'll be able to select each inventory item and calculate the depreciation over the next 5 years based on the value of that item and whether your depreciation is straight line or double. So the difference there is some items depreciate faster than others. For example, a vehicle. Okay, the vehicle you're using every day, it's going to get damaged and it only has so many years of life. So that might depreciate faster than something like a refrigerator, which might last 10 or 20 years. So you have different ways of calculating. We're just going to write different procedures for creating straight line and double declining depreciation. So this is basically the application we'll be creating. And this is the data that is going to be in our text file. And I'll talk about this a little later, and we'll talk about it in the guided program walkthrough. When you're working with arrays and reading files and writing files, the most important thing is to understand the data that you're pulling in. So this is kind of all the data that's going to be in the text file. So we have our inventory items, our cash registers, our signs, our food trucks, our storage freezers, our stove, our office computers. We have item numbers for each one of those, cost and how many we own, and then we'll calculate the depreciation on that. So this will all be inside a file for us, and we're going to read this into our application into an array, and we'll use that to calculate our depreciation. So when we get into the building the application, we'll actually open this file and look at it, and I'll show you how we kind of figure out what's in the file and how we're going to work with it and how we build our arrays based on this data. So an array, or an array variable, is simply a variable that can store more than one value. Each element in an array that contains a value is called an element. Arrays provide access to data by using a numeric index or subscript to identify each element in the array. So your array is just a variable that holds multiple items. So most of our variables, you declare a string or an integer or a decimal, and you put one value in there. With an array, you're going to define how many elements are in that array, and then you can put multiple values into it rather than just one. So if you had multiple values, you could actually declare, rather than using an array, you could declare, in this example, we have 5 different variables for different reservations. And you could do that, right? You could declare 5 different variables, but if you don't need to, you shouldn't. So we have this thing called arrays that will hold multiple values of the same type. In this example, it's reservations, and in the example below, it's shoe sizes. So we have a shoe size for, it looks like it's 1, 2, 3, 4, 5, 6 elements, and all the different shoe sizes. So we could do that with 6 different variables, or in the above example, with 5 different variables, but it's a lot easier if you're using arrays. So to declare an array in a program, you must include an array declaration statement, which states the name of the array, how many items it can store, and what sort of data it can store. So this is very similar if you're declaring arrays to just declaring a variable. The only difference is you have to give it the number of items. So in this example, we're declaring, so dim, our variable name, and then we have this little parentheses. This is how many items are in the array. So this is blank in this example because we're specifying the number of items here at declaration. So just like setting, if we had just a regular string declaration, we'd set it equal to just one variable. So in this item, we're setting it equal to 1, 2, 3, 4, 5 values, okay? Same thing here. Reservations as integer, we have 5 values in here in this array. So the only difference that you can see here is really this parentheses. And we could actually put a number in here as well and just declare a 5-element array or a 10-element array, whatever it may be. Just different ways of doing things. So our first question here is, how do you tell the difference between an array declaration and just a regular variable declaration? So when you're looking at a declaration of an array, how do you tell the difference between a regular variable and an array variable? So parallel arrays store related data in 2 or more arrays. So sometimes you might need to have multiple data, but it's related. So in this example, we have reservations. So we have 1, 2, 3, 4, 5 names and a reservation number for each one of those. So we have the name and the reservation, and those are related. So you could have 5 or 6 of those in the guided program walkthrough. I think we're probably going to have 4 different parallel arrays that hold data that are related to each other. So item 0 goes with item 0, item 1 goes with item 1. And this will make more sense when we start working with our data in our application. So in this example, whoops, just want to pass that. In this example, whoops, what just happened here? There we go. All right, so in this example, we have an array declared. In this example, we haven't set our values we're putting in our array at declaration, but we are declaring a 5-element array. So dim string athlete, 5 elements as string, okay? And then you can see we're setting our first element as football, our second element as soccer, our third element is lacrosse. Notice something weird about this. We've declared it as 5 elements, but there's actually 6 elements in here. 1, 2, 3, 4, 5, 6. That's because in our array, we start with 0. So there's actually, so if you want a 6-element array, you declare it as 5. Because remember, we're always starting at 0 when we work with data and arrays. So that's kind of an important thing to keep in mind. You're always going to be 1 less. It's always better to have an array that's a little bit larger than an array that's a little too small and doesn't have enough data in it, because you're going to get errors if you try to put items into an array and there's not enough room. So it's always better to declare your array a little larger if you don't know how many elements you're going to be going into. But we also have redim, which allows you to resize the array at runtime as you're going along. So we'll talk about that a little later as well. So when you initialize an array with default values, and you don't put any data in there, if you don't assign those values at runtime, if you declare a numeric array, the default values are going to be 0. If you declare a string array, all the values are going to be null, which is nothing, empty. And if you declare a Boolean array, by default, the values will all be false if you just set the default value and if you don't give it any values. Something interesting to keep in mind if you're not putting values in when you declare it. So typically when we access the items in an array, we access them using a loop. So in this example, we've got an array with 31 elements, actually 32 elements because it's 31 because we're starting at 0. So we're declaring our array with 31 elements. Got a couple of variables for our temporary string and our days. So we say for int day 0 to 30, we grab a value from the input box, okay? And then in this line, we're taking that variable from our input box and putting it into our array. So here, int days, this is our index or array. So we're going to start at 0, right? So int days is going to be 0. 0 is going to put our first element in. We're going to loop again. Then this int days is going to turn to 1. We'll put our second element in. We'll go through all the way till 30. And we're going to have a little extra room in this array because it's declared with 32 elements because it's a 31 element array. So the Visual Basic compiler will determine if your subscript is within the boundary set when you initialize the array. So in this example, we have a 30 element array, and we're going 0 to 31. So that's going to cause a problem. This is going to error on us when we actually run this program. When it gets to the last one, it's not going to be able to get to 31 because we're starting 0 to 31. So that's too many items. That's going to cause an error for you. So as I previously explained, the exception occurs when the loop tries to reference an element with subscript 31. The element does not exist because the array contains 31 elements with an upper bound index of 30. So you're going to get this system out of range exception, indexes outside of the bounds of the array. If you're working with arrays and you get that error, it's because your array you declared is not large enough. You're trying to go beyond what the bounds of that array are. So it's something to keep in mind when you're working with your applications. Some of you may get errors on that as you're going through. So an array can use constant values to represent its upper bound index. By using a constant, the size of several arrays can be specified quickly. As you'll learn in the next section, they can also be changed quickly. So if you're working with multiple parallel arrays, and they're all going to be the same size, you can use a variable to specify the size of that array. So in this example below, we've got a constant int upper bound is integer 40, so we're creating a 40 element array, and we declare the string first name and string last name, both of those using this variable as a 40 element array, or really a 41 element array. Every array in Visual Basic is considered dynamic, which means you can resize it at runtime. When you change the number of elements in an existing array, you redimension it or redeclare it. The redim statement assigns a new array size to the specific array variable. So we've declared this array with 50 elements, and then later in the code you can redeclare that array as 65 elements. Keep in mind when you do this, redeclare an array, or redim an array like this, it's going to wipe out all the values in the array, which you may want to do, but sometimes you may not want to do that. If you want to preserve the data in the existing array, you can use a keyword preserve. So this redim preserve, string employees 65, that's going to keep the original 50 items in that array and not wipe it out. If we don't use that preserve keyword, it's going to clear out all the values in that array that we declared, if there was anything in there. So a very important thing to keep in mind. The length property of an array contains a number of elements in the array. So in this example, we're saying array name.length. That's just going to give us the number of items in that array. Very useful thing. If you don't know how many items are going to be in your array, if you're doing some redims, you can just use the array name.length -1, obviously, because we're starting at 0, and that'll give you the number of items in that array. So a couple other examples using arrays. So this one, we're declaring our array with yearly salaries, 9 yearly salaries or 10 yearly salaries, number of employees. So we're looping through that array, this variable, and each year we're adding a value to the yearly salary to total them all up. Okay, and then at the end we print it all up. And in this example, whoops, too far. In this example here, we're just using our array to populate a list box. So we have int fill, 0 to the length of the array. So for each item in that array, we're adding the item ID, which is our array name, and the index. So we're going to start at 0 and all the way through the length of the array. So that int fill is the index. So the for each loop is a different kind of loop, kind of like the for next, but this one, this loop is used specifically to work with arrays. So this type of loop iterates through an array until the array reaches its last element. So we have the control variable name. This variable will contain each individual element in the array without a subscript as the loop is processed. During the first iteration, the first element in the array is assigned to the control variable. Then we have the array name. This is the name of the array that we're looping through. And then we use the next keyword as we would in a for next loop. So here's an example of that. Sometimes the students kind of struggle with understanding the syntax here, but basically we have here string famous computer pioneers. This is our array, and we're putting 1, 2, 3, 4, 5 values in it. Okay, so and then we're adding each of those items to our list box. And then for each value in an array, we add it in. So we loop through each item in string famous computer pioneers and add them to our list box. So question 2 is what type of loop is used exclusively with arrays? It's not a for next. For next is what we talked about in the last chapter. What kind of loop is used exclusively with arrays? So the scope of array, we've been talking about scope of variables all along. The scope of an array is declared within the procedure as local to that procedure, but an array could be declared at a class level. So an array is just like any kind of variable. If you declare it inside a sub-procedure, it's local to that sub-procedure, but if you declare it at the class level, you'll be able to use it anywhere. Okay, so scope works the same as arrays as it does at any other value. So keep that in mind when you're declaring your variables. An array can be passed as an argument to a sub-procedure or a function procedure. So just like in the last chapter, with function procedures, we are able to pass values as arguments or parameters to a function. You can pass an array the same way. So this is just an example of that. So we've got our sub-procedure changed by value, value of commission here, and this is an array, a decimal array that we're passing in. So no different than a regular variable. A couple functions that we have with an array that are pretty useful is you can sort arrays. So the data that you put into an array could be in some crazy order, and you might want to put it in alphabetical order or numeric order from highest to lowest, and we have a sort procedure as part of the array that allows us to sort those variables. So to sort array content in Visual Basic, you use a procedure named sort. When the sort procedure is applied to an array, the lowest value is placed in the first element in the array with an index of 0. Next lowest value is placed in the second element, and so on until the largest value is stored in the highest element. So it does just what it says, and it sorts those values inside the array. You have to be careful doing that if you're working with parallel arrays, because if you sort the different arrays, they're going to be all put in different order, and you'll get the indexes messed up. So you only want to do that if you're not using parallel arrays. So this is just the syntax for it. It's just array.sort and then the array name in parentheses, and that's just going to sort your data for you. Pretty simple. You can also search an array. So searching each element in an array is called sequential search. The binary search method searches a sorted array for a value of string using a binary search algorithm. The binary search algorithm searches an array by repeatedly dividing the search in half. So you'd want to use that if you had a really large list of values. It just goes faster if you use a binary search. And the syntax for that is just array.binary search, array name, and the value you're looking for, and then it returns the index of the value you were looking for, so you know where to go to get that. So we also have two-dimensional arrays. We won't be working with any two-dimensional arrays in this chapter. They can get a little bit complicated, and typically when you start working with two-dimensional arrays, you should probably be using a database table rather than just text files. But you can do it. So you're just specifying the number of rows and the number of columns. So rather than just a list of items in your array, you have kind of a table, a grid of data. So in this example, we have 2 rows and 3 columns. It's really 3 rows because it's 3 items and 4 columns. And then you can populate that data. In this example, you're using a nested for loop to iterate through that data. So we have here the data we're populating at runtime, the passengers. So we have 35, 34, 27, and 28. So we've got 2 columns and looks like 4 rows, 1, 2, 3, 4. And then our nested for loop here will go and iterate through and calculates, it looks like it calculates the sum of the data in our array. So the next thing we're going to be talking about or working through in this chapter is file handling. So to process data more efficiently, sometimes developers use text files to store and access information to use within an application. When we think of text files, we think of files that you would create in Notepad. So just a simple file with a txt extension that has data in it, some simple data. And sometimes you might want to just store data simply in a text file rather than in a database. Sometimes these are also called sequential files. So you would typically open these with Notepad, and they're just simple files. So to open a text file, you need to use an object available in the system I/O library called StreamReader. So when you're going to be working with files, the first thing you have to do is use this command, dim object reader, as I/O stream reader, and that's the library within Visual Studio that allows you to I/O as input output, so that allows you to work with the file system to open a file and read what's inside it. So in this example, we say if I/O file exists, and then we give it the path of the file. So this is what you have to be aware of. Where is your file located that you want to read? So in this example, it's an E drive, so that's probably a flash drive, and it's in the root. So if you're specifying a file, you have to know the path. So you're going to have to know how to navigate to where that is. So if you have a Visual Basic folder, it's going to be E Visual Basic / inventory. And if you have a complicated location, you're basically hard coding the location of that file. Something to be aware of. Sometimes if you're working with one computer, you have multiple flash drives in. Sometimes it might be E, sometimes it might be D drive, sometimes it might be F drive. So it's important to keep an eye on when you plug your flash drive in, what it is assigning to. Is it assigning to an E drive? C drive is typically your computer. Your F drive could be a flash drive, but again, you can have multiple USB ports that you can plug flash drives in, so it might not be specifically what's specified here in the code example. So just something to be aware of. So we try to open the file if the file exists. We open it. So we open text, and if the file does not exist, we display a message box to the user. The file is not available. Restart the program. We probably don't want to say restart the program. We probably want to say check that the file exists where you think it is. And then this example, we're just closing the file. If we were able to open it, then we could go and read the line in that object reader in that file and put it in an element of the array. This would probably be done inside a loop, this example right here. And there'll be some examples in the next slides on how we actually do that. So determine whether the end of the file has been reached, because we're going to be reading through the file, multiple lines of that file. So you use this peak procedure. So you do while the object reader.peak is not equal to -1. So object reader.peak will return -1 when you get to the end of the file. So in this example, we're reading a bunch of lines out of the text file, and we're reading an inventory item, an item ID, a price, and a quantity. And we're just going to read through that file looping until we get to the end of the file. And when we get to the end of the file, this peak is going to be equal to #1. It's going to stop out of the kick out of the loop. And then we always have to do object reader.close. We have to close that file. If you forget to close the file and you're running the application multiple times, you're going to run into problems because your program is going to have the file open. And you run the program again, you won't be able to because the program already has it open, and you'll get some errors on that. So always make sure you're doing this object reader.close. That's something you see in applications a lot of times when you're getting errors, and we talk about memory errors and not declaring variables properly, or declaring variables with the wrong data type. Not closing objects when you're working with files is something that can cause a lot of memory issues. So you have to close those files. Your computer might be running slow. It might be because an application you're using is opening files and the developer never actually closed that object. So it's leaving things open in the background that are eventually going to use up all your memory. So very important to do that object reader.close when you're done working, when your program is done using the file. If you don't do it, it's gonna leave it open in the background. So like I said, after you're done your loop, you close it, and then in this example, we're closing the application if the user got an error. Same with reading a file. You can also write a file. So sometimes for reporting purposes, you might want to have your application write out to a text file. We use this a lot. In my career, I used it a lot for error messages. So within the application, there would be places if the user did something weird, or there was some weird message, if the user got a weird message or something like that in the code, I would write out that error message and some other information about what was going on, so that if the user called and they said, "Oh, I was having a problem, but something popped up on the screen, I got some error," you could just say, "Okay, go to this location in your computer. There should be an error.txt file. Open that text file up," and my stream reader would put the date, the error, what screen they were in, just give me some information so I could find out exactly what happened when they were doing what they were doing to cause this error to happen. So we'll talk about a little bit about that in a second. So the third question is, what are the two objects used to read and write to files? One of them is on the screen that I'm looking at right now. So the third question is, what are the two objects that are used to read and write files in Visual Basic? So this is just an example of creating a file. So we declare a 6-element array here with customer names and passwords. We declare our object writer as a new stream writer and give the path of the file that we're going to create. Initialize a loop. And we're going to loop as many times as we have customer names. So we're going to get our first customer name, and we're going to get the password from an input box. And then we're going to check that we're able to create that file. And then we're going to use object writer write line, and we're going to write that customer name that we accepted back here, and we're going to write it into our file. And then if the file wasn't available, we're going to display a message box, and we're going to loop again, and we're going to get the next name. So we're going to just be accepting 5 customer names and passwords and write into a file. Probably not a good thing to do, write passwords to a file unencrypted, but this is just a simple example. I know I've talked about a lot of companies saving passwords in databases and files unencrypted. So probably something you shouldn't do, but this is just an example here. A bad example of that, though. We talked a little bit earlier about computing depreciation. Depreciation is the decrease in property value and the reduction in the balance sheet value of a company asset to reflect its age and prolonged use. So companies buy assets. They buy computers, they buy trucks, they buy machinery for manufacturing. And as that machinery gets used, it decreases in value, and companies can write that off as a tax advantage, so that it helps them buy new items. So the simplest and most common method of depreciation is straight line depreciation. It's calculated by dividing the purchase or acquisition price of an asset by the total productive years it can reasonably be expected to benefit the company, which is called life of the asset. So if you have a vehicle, that might have a 5-year life. If you have a machine for manufacturing a robot, that might be 10 years. If you have something else, it might be longer or shorter. So that's something it's a kind of a tax code that you figure out and you look up, and then you can use your depreciation values and you can write items off for taxes. So that's what the guided program walkthrough application is going to do. So we also have double declining balanced depreciation. It's like straight line method, but just doubled. So certain items will depreciate faster than others. For example, a vehicle that's getting used every day, a truck that's driving across the country delivering things, maybe you won't get 5 years of life out of it. Maybe you'll only get 2.5 years of life. If you're a police department, those police cars get used a lot, so they might depreciate a lot faster than a school bus, for example. So the last thing we're going to talk about in this chapter is multiple form objects. So most of the applications we've developed so far this year just had one form, except for the splash screen stuff. That was kind of our introduction to multi-form applications. But in this chapter, we're going to be developing some applications that have more than one form. And you'll notice, as an example of our Solution Explorer here, you see we have 2 different forms there. And you can have 2, 10, 20, 50 different forms in there. So the important thing to keep in mind when you're working with applications with multiple forms is you have to specify the startup object. So the application has to know, if you have multiple forms, which form you want the application to start with. And you specify that in the application properties. And when we get into the guided program walkthrough, I'll show you how to do that. So that's kind of the most important thing to think about. Before you start running that application, you may add 5 or 10 different forms, but you have to tell the application, okay, this is the form I want to start with. Probably a login screen or something like that. But if you don't have a login screen, it's going to be whatever form you want the application to start up with. So there's this startup form option. You're going to click on that drop down. It's going to list all the forms you've added. You just click on the one you want it to start with, and that's the one that'll be the startup for. So the fourth question that I want you to answer in your Word doc is, what is the significance of the startup object or the startup form when working with multi-form applications? So why do we need to reference a startup object? All right, so when we have multiple forms and you want to display a second or subsequent form, the initial step is to create an instance of the Windows form object. Okay, so when creating multiple Windows form objects, Visual Basic allows you to generate 2 types of forms, modal and modeless. So kind of different ways to display forms on your screen. A modal form retains the input focus when open, and a modeless form allows you to switch the input focus to another window. So you can have a form that pops up, and you can only work on that form, or the user will only be able to work on that form. There might be something else in the background, but until they click close, they can only work in that form. If you have a modeless form, you can have multiple forms on the screen that are available to the user. They can just click over to the other one and enter some data in that screen. And there's specific instances where you might want a modal form. So if the user's entering data and they need to save it, you don't want them to leave that form until they've actually saved it. So most cases, you're going to do a modal form. Modeless, if they're not saving data, if they're just clicking on things and displaying data, modeless is fine. But you want to be careful about allowing the user to have too many forms up at the same time, because that can get confusing. And to display another form in your application, you're just going to say the form name.show, and that's going to show the form to the end user, the new form you want to display from one form to another. You control the availability of a variable by specifying its access level or access specifier. So sometimes you're going to declare a variable or an array or whatever it is on one form, but you want to reference that array on another form. In order to do that, you have to declare those variables or arrays as public shared. Okay, public shared is going to allow that array to be referenced from another form. If you just declare something as private or just declare it, you will not be able to reference it at another form. Only public shared will allow you to do that. So when there's an instance where you do need to reference an array on another, that you declared in another form, make sure you're declaring those as public shared. And that is all I have.